Hi! In this lesson, I'm going to talk about the discovery of the electrons. Okay, so who discovered the electrons? Well, it was the British physicist J. Thomson. He discovered it in 1897 with his co-workers. Okay, so as you can see here, he's using the apparatus which is called the cathode ray tube. Well, that drawing looks a little bit hard to understand. What is that? Well, it's the cathode ray tube. Well, you can think about it something like this bottle. It's empty, but it has inside it two iron coins. One which has a hole inside, and the other one without a hole, and we call them as electrodes. Okay, so of course, what did he do? Is that he emptied that bottle. He removed all the air outside and became vacuumed. But why did he do that? Well, he did that because, as you can see, he connected it to a battery. And to make electrons or energy to flow easily, he needs if electricity wants to move, then we need a vacuumed place so we don't have air pressure. We don't need any pressure. But at that time, they didn't know what is electrons. They didn't know that electricity is just simply electrons moving. Okay, so J. Thomson took that empty glass tube out of air, and placed those two electrodes. Now, what is that job of those two electrodes? Well, as I said, this is the cathode ray. But why is it called cathode? Because the ray is coming out of the cathode. Okay, so always remember, we're going to talk about it later in the other lesson. Cathode is always in the negative side and anode is in the positive side. Okay, so let's start. He connected them to a battery, and then as soon as he connected them to a battery, a ray was shot. Now he saw it glowing in here. Why? Because he had like special type of fluorescent screen that glows when electrons hit it. And of course he didn't know what is electrons. So as soon as this ray hits it, it will glow. Okay, so what happened here is that we have that cathode is shooting the electrons. So the electrons are going through that anode very quickly. So it went through it and was shot till the ending of the bottle. So that's what's happening. Okay, but what's interesting about it? What made him discover the electrons using that cathode ray tube? Well, he said, what is that ray that was shot? And does it even have a charge? So what did he do? J. Thomson took two metal plates that are charged. One positive, other one is negative. And then he tried again. He connected to a battery, and again a ray was shot. But guess what? What happened here shocked him. What happened here is that the ray didn't go straight. It tilted towards that plate. But why? Well, he concluded that that ray, or the cathode ray, should be negatively charged so that it can be deflected from that negative field and get attracted to that positive field. But he didn't stop here because he's a really careful guy. So what did he try now? He removed those metal plates, and instead of the metal plates, he replaced it with a magnet. Okay, now the magnet, it will be a little bit hard for me to draw it because it's just drawing, but I just want you to think about it something like this. Imagine this is the cathode ray. This is the ray it's getting shot. Or let's say this is the ray. So the magnets, which is going to be my fingers, will be here. This is going to be the bottle or the glass tube, and it's going to be placed here. The glass tube is here and the magnets are placed under it. Let's say this is the positive and this is the negative. What happens is that when the ray goes through, it will again get attracted to what? To the positive side. So let's say this is the positive side and the negative side is here again from the magnet. It will look something really weird. Okay, so what happens again? He sees that the ray is deflected from the negative and attracted to the positive. And he didn't stop in here because he thought, or he's, as you said, he's a really careful guy. So probably that ray was shot maybe because of the type of the metal. So he decided to change the metal. Let's say he was using copper. Let's say he used any metal. He used, for example, copper. He's changed it to another metal. For example, let's say any other metal like zinc, for example. Or yeah. So he changed it to any other type of metal and shot it. Again, the ray still got attracted to the positive charge and deflected from the negative. Changed it again, the metal changed it, and still the same answer came out. So I think some of you didn't still understand why did he use that experiment. Well, he concluded from that experiment that that ray that was shot was attracted to the positively charged field, magnetic field. But why? We know that always same charges repel or push each other out, and different attract each other. So he said if the ray was getting shot through the magnets or the metal plates, and the metal plate is positively charged and it's attracting it. So does that mean, so the opposite side of a positive charge is the negative charge. So he concluded it's negatively charged. And to check, the negatively charged should push it away, and of course it will push it away deflected up to the positive. So that proves that it's a negatively charged particle. So that's not it. This is only the discovery of the electrons. And how did he use the cathode ray tube experiment to discover the electrons? Why do we use it in chemistry? Usually, and these days, they were trying to create an atomic model. So J.J. Thomson, after the discovery of the electrons, had made his own model of the atom. And he called it the plum pudding, which is a British dessert. And of course, we can't say no because he's British and probably is going to put something from his country's food. So he said that the atom is something like this. Electrons, for you the people are not familiar with the plum pudding, let's say a much familiar food, which is the blueberry muffin or a watermelon. Let's start with the blueberry muffin. Imagine this is the atom. Randomly electrons are spread around, and of course we have protons also. But the protons are in the dough, so they're also randomly spread. So they're going to be spread. So the protons will just be randomly spread also. So just like plum pudding, you can think that as the dough is the positively charged, so the atom is positively charged, and electrons are randomly spread in. But not all the atoms positively charged. It has some positive particles inside, and the negative particles are just randomly spread. So that's how you can think about it. Now, of course, this model is wrong. You can also think about it as a watermelon. I will tell you why it's wrong. So it's a watermelon, negatively charged. The flesh of the watermelon, you can think about randomly spread positively charged particles. So he's the one who discovered the electrons. But his atomic model of the plum pudding was disapproved in 1907 from the scientist, the physicist, Ernest Rutherford. Okay, So we'll talk about it in the next video. But you should always remember that J.J. Thomson had discovered the small particle or small subatomic particle which is called the electron. And he concluded that that subatomic particle is thousands and thousands smaller than a hydrogen atom. So that's about the discovery of the electron, and I hope it was useful.